Good morning, class. I'm going to go through the practice exam with you, and ideally, you will have gone ahead and done the practice exam yourself first, and you're coming now to kind of check your work and make sure that you're following the process correctly. So if you haven't done that, you might actually pause the video now, go do the practice exam on a piece of paper, come back, and then we'll go through it together. So there are a couple differences between the practice and the final exam. One of the big ones is instead of putting all of the diagrams with the questions, they're moved to the last page. This is an old practice exam. I've done this for a while. One of my students made the suggestion that way you could pull off the last page and use it as a reference as you're working throughout the entire class. So the final exam actually has two sides of notes on it that are UML diagrams, a table of the different data that should be generated, stuff like that. Okay, so we have a simple UML diagram. We have an enum of pie filling with 4 possible flavors of pie filling. We have an order item interface, which is similar to the one that you guys have been working with, but different. So do be aware that may not match up entirely. We have this Paleozoic pie. This was from when we had a dinosaur-themed restaurant. And so we have a filling, which is part of one of that enum. We have the a la mode, which is a Boolean property, and we have hot. And we know these are properties because they have the get and the set as stereotypes in the UML. We also have a constructor which takes in the filling that it's going to have, and we know it implements the iNotify property changed interface as well. So it implements both these interfaces. So our first challenge is to write the pie filling enum definition modeled by this class diagram. Notice I've given you the namespaces, so you don't need to worry about the namespace. We just need to write this enum. So an enum, of course, public enum, the name, which is pie filling, and then we put in our values. And our values are apple, blueberry, cherry, and peach. And that's really all there is to an enum. Since we don't have default values for these, it makes it pretty simple. If we did set a value like apple needs to be 1 or 2 and blueberry needs to be 5, then we'd have to go ahead and add those. But in this case, this is about as simple as we can get with an enum. So that's a nice, easy one. Also, I want you to do these on paper if you can. I don't have a document camera to actually be recording me writing this down here. I do at the university, but I'm not at the university, so I'm doing this in Notepad++. If you do end up doing it in a text editor, please use something like Notepad++, not Visual Studio, because I don't want you to have all of the prompts that Visual Studio gives you. I want your own unadulterated work, so what comes out of your head and goes on to the code, not the assistance that you get from the built-in tools of Visual Studio. For this exam, consider Visual Studio to be unauthorized aid. Okay, so that was our enum. 2, write the Paleozoic pie class as definition as modeled by the UML diagram. And then we have the description should be the filling followed by Paleozoic pie. It's $3 plus an additional dollar when served with ice cream. Serving the pie hot or a la mode are considered special orders, which means they go in the special instructions. Remember to implement the interfaces fully. Okay, so what do we need to do here? We have a Paleozoic pie, public class Paleozoic pie, and it implements the iOrder item and the iNotify property changed. Interfaces, so we have to have those there. Okay, so that's kind of the start. We know that if it's implementing iNotify property changed, it has to have this event defined, property changed event, which is of type property changed event handler. So public event property changed event handler property changed. And that's it. That's how we declare an event. It looks a lot like a field. The only difference is we have the event keyword in there as well. The type is property changed event handler, and the name is property changed. These are defined by this interface. It needs to match those exactly. for it to be correct. Okay, so that implements this interface. We're done with it. For this one, we need to have a getter for the price, description, and special. So public. And in our code, we were using decimals. Here, it's actually listed as a double. So public double price, and that needs to have a getter. And what does that price look like? Well, let's go back to our description. The Paleozoic pie is $3 plus an additional $1 when served with ice cream. So that would be, let's actually do it, double price equals $3. So that's our default. And then if a la mode, which is a Boolean, so we can put it straight in the test. And let's make sure we spelled that the way it wants, a la mode. So if this Boolean is true, we're going to add 1 to that price, $1. And then we can return price. That should be our price. And then we have description. Oops, it's not going to be inside the property. And you might be wondering, do these need to be overrides? Well, in this case, none of these are base classes, these are interfaces. You don't override an interface method declaration, you just have to have it there. Because remember, with an interface, it's a contract saying I'm going to have this method. With a base class, it actually provides that signature and we have to override it. So no overrides in this particular instance. Then we look at description. And we've come down to our write-up. The description should be the filling followed by Paleozoic pie. Well, let's look at our fillings. We have apple, blueberry, cherry, peach. So we're lucky none of these have spaces or would need spaces in them. So we can actually just do a very simple getter where we'd return the pie filling enumeration value and add to that Paleozoic pie with a space, and be sure to add the leading space here. Now this pie filling, when it's concatenated to a string, when you concatenate anything to a string in C#, it invokes its toString method. And the enum, its toString method, actually takes these labels and turns them into a string. So we're good. Now where we get tricky is if this is a compound word and it's declared in camel case, there's no spaces. When it turns into a string, it keeps it in camel case, and we'd want to split that out to make it read better. But we don't have to worry about it in this case because they all are just a single word. No compounds. So description, and then we also need to implement the special, which is an array of strings. In the assignments you've been working on, that would be the special instructions, I think. That's what we called them there. And a la mode was a special instruction, and hot was a special instruction. So those are special orders. I don't give you a ton of detail on this one, so we just know that we need to give that information out somehow. So let's do a list of string. And we'll do a list because it's easy to add stuff to a list. So we can say if this is a la mode, special a la mode, so with ice cream. If the hot Boolean is set, serve hot, something along those lines. Then we can return special, which is a list at this point, to array, which is going to turn it into an array of 0 elements if it's empty, 1 element if we either said a la mode or hot, or 2 elements if it's both a la mode and hot. So this is an easy way to get that array back out, but make it easy on us as we're building up that array, because we can actually do it as a list and then switch back. Okay, so that takes care of this interface. We still have the Paleozoic pie. We need to define the pie filling, which is just named filling. So a public filling, pi filling, and we'd love to be able to do the auto property, but we can't do the auto property because we are implementing iNotify property change, which says whenever these properties change, we need to notify them. Now these ones we don't need to do that on because these are all getters. And a get is not where the value actually changes. That's just where you get the changed value from. So that's not the appropriate spot for it. However, setters always change the value of the property. If they're not changing the value of the property, you're not using a setter correctly. Or it's failed some validation test, one of those two. But we should be trying to set the value there. So we will need a getter and a setter method for both of these, and we need a private backing variable. Private filling, and that should be a pi filling. And if there is a default set here in the UML, there is not. And if we go through the description, there's not. So we can just let it default to Apple as actually what it's going to end up being in this case, and that's fine. So our getter would just return a private variable. So we get the value out of it. And our setter would attempt to set that. Filling equals value, because value is what we get from the setter being set. And then we have to do the property changed invocation. And JavaScript this. So this object, this particular Paleozoic pi is what is changing, and the property that's changing is property changed event args filling. Now, does changing the filling change anything else? Well, the filling does not affect this, but it does affect the description, and it does not affect the price. So we also need to notify that the description is changing. All right, that's our filling. We've got that one done. And then the next one we have is the order item. Oh, we're in here, filling a la mode, which is a Boolean. And I've been spending too much time in JavaScript land where we put our curly braces after the definition. Then we're going to do get and return la mode. So we'll have a private backing variable for this one as well. Set and la mode equals value property changed. Invoke this new property changed. And doing la mode. Change anything else? Must, or I wouldn't be typing this, right? So what else do we change when a la mode changes? Well, special has a special message if a la mode changes. So special will change. And price increases if we're at a la mode. So we actually need two extra property changed here. All right, that's all in mode. Oh, we need a private backing variable still. And the last one we need is hot. There's also a Boolean. And again, we'll do a private backing variable. Now, one of the things you can do is you can check to see if the value and the prior value are the same, and if they are the same, you can skip this whole property change stuff because there's nothing to change, but you don't have to. So there's different ways you can write this up, as with everything. So we're going to invoke this new property changed event args hot, because the hot property is changing, and property changed invoke this new property changed event args, and hot we change the special, we don't change the description, we don't change the price. So just special. And these have to be spelled right or they're not going to work, as some of you have discovered. Okay. Then we can go ahead and add our private variable again, private backing variable bool hot. And this is supposed to start as false, as is all in mode. We'll go ahead and set those. Now in this case, a Boolean variable starts at false by even if we don't set a default, so we don't have to in this case. If they were true, we would definitely have to set the default value. But it's good to be clear that this is our intention. We make that intention clear when we actually set the default, rather than just letting it fall back to whatever the C# language definition calls for. Okay, so that wraps up those. We still have this method. We have to do a constructor because this one calls for a constructor. So a public Paleozoic pi, and it takes one argument, which is the pi filling. And if we're taking that in the constructor, we can probably assume we want to set this filling right there. So underscore filling equals filling. And you might wonder, do we need to invoke property changed at this point? If we're doing it in the constructor or in the initializer, if we're using initializer syntax, those will all get done before this gets handed to anything that's going to be listening or attaching to that event listener. So there is no need to do the property changed event or property changed event invocation within the constructor or within an init property if you're using an init property. But otherwise, yes. We would want to do that, but not here in the constructor. So this is really all we have to do for our constructor, because all our other values are preset. We could set all in mode to false and hot to false here, but we already did that in their definition, so it's taken care of. So that should take care of that. Is there anything else we need to worry about in here? I think we've covered everything. So we should be good. We got the 3 plus the $, and we got the special orders. We did the interfaces fully because we are actually invoking the property changed where we should. All right, complete these tests of Paleozoic pi. So we have a Paleozoic pi test. Default price should be correct. Well, we know from our description up above the default price should be $3 because we're not all in mode by default. So this test would look something like public void default price should be correct. And I'm just adding this because I'm not actually writing on the test. You just need to write the interior part or the body of this method call. So we can create a new Paleozoic pi, and remember our constructor, because we don't have a parameter list constructor, we do have to give it a filling. I like cherry, so I'm going to do a cherry pie because it really shouldn't matter. The default price should be the same no matter what the flavor is. And then we want to assert that default price equals our expected price of $3. So that's our expected value. Pi.price is our actual value. And that's all we have to write. Whoop. No, actually we don't. Yep, just like that. So that is our full test for the default price should be correct. Pretty straightforward. Now we have a theory about the filling. Description should reflect the filling. So we have the pi filling. There's a lot of different ways we could do this. So first of all, we need a pi. And we're going to go ahead and set it to have the filling that we specified. So we want to make sure that the filling reflects this. So if it's apple, it should have apple in the description. If it's blueberry, it should have blueberry in the description. If it's cherry, it should have cherry in the description. If it's peach, it should have peach in the description. So we could, for example, test that it is exactly the string that we're expecting. And if that was what the description should match expected or something along those lines, that's what I'd say we're actually testing for. So let's match the exact string. In this case, we just said should reflect the filling, which I think gives us a little bit more wiggle room. We just want to make sure that the right flavor is in there, and that way if we change the description, how it actually is rendered at some point, we're just really worried about does it say what kind of pie it is. So with that, we could do an assert.contains. Now there's two versions of assert.contains. There's one that works with strings and looks for substrings. That's what we're going to use today. There's also one that works on collections and looks for if there's an actual element in the collection or item in the collection. So the string one, we would say pi.description, because that's the string we want to look through, and we'd look through it for filling. And we want to make this to string so we get the actual string value of that filling. So if this was cherry, it would look for the substring cherry in the description, and it should be there. If this is a Paleozoic pie set to cherry, which is what we set up here, so that should match, and that will run through and iterate for each one of these pie fillings. So we'll check for apple, blueberry, cherry, and peach. And then we have one last one. It looks like we have our test down here. Paleozoic pie equals a new Paleozoic pie with a cherry filling. And we're asserting that the property is changing. So when we change this filling, pie filling property, we expect to have a property changed event fired off. And this property changed event arg should say the property that is changing is the filling property. So what do we put up here? Well, this is where we would put our theory or fact. And since we're taking this property changed, it doesn't look like we're taking any outside variables here. So this is probably a fact. And we need to give it a name. Public void should invoke property changed. Something along those lines. It just reflects that we know what this method is actually testing for. And that wraps up that one. Okay, now we're on to a code listing. So we will also have some problems with code listings. So this is written code that we're going to ask some questions about. So in this case, we've defined a vector, and it has 3 private backing variables. We can turn it into a string, and it does kind of a classic angle bracket vector definition with the values separated by x's. We can construct it, supplying the x, y, and z. We can calculate its magnitude. We can normalize it. We can add it to another vector. We can subtract it from another vector, and we can scale it. So draw the UML diagram for this vector3 class. Let me fire up paint. And I'm actually going to, whoops, that was not helpful. Stop doing that, Windows. You're not helping. All right, let's get this description back up. Let's start there. So my advice on drawing UML diagrams, don't draw the box until you're done, or just draw the top and side, the right side, because you never know how long you're going to need your words to be. So the first box is the class name. So in this case, vector3. It's not static. It's not inheriting from anything. It's not doing anything special. It's not abstract. So it's just the name, vector3. Then we have these three doubles, which are not declared as public, so they are private. That's kind of a weird choice. These probably were intended to be public, and somebody just made a mistake, i.e. me. But because they are private, we'll mark them with a negative sign that indicates private. Plus means public, and the tilde, which is this squiggly guy, means that they're protected. So these are private. It is a variable named x, and its type is double. So that's the first one. The second one is y, double. And these are fields, so we won't have the get and set stereotypes. Z, double. And that is it for fields and properties, which go in the very first box. So that pretty much wraps up that one. Let's go ahead and just start another box down here for the methods. So let's walk through our methods. We have toString, which is an override. So toString, and it has no parameters, so the parameter list is empty there. And we do a colon and the return type, which the return type is string. And then this is an override, so we want that override stereotype to show that this is an override. And then we have a constructor. So to show a constructor, we do vector3, the name of the class. It takes three arguments, x, which is a double, y, which is a double, and z, which is a double. And we don't have a return type because it's a constructor. So we leave that blank, and that helps indicate that this is a constructor. And we have magnitude. Look at that. That is actually a property, isn't it? Because it has a get. So this actually goes up in that first box. So we're going to move and just put one up here. It is public. So public magnitude double. And because it's a property, we're going to show its property with a getter. There is no setter, so we don't need that. Normalize. Oh, actually, these guys should have a plus sign in front of them because they are public. So we'll edit that a little bit. Paint is not the easiest one to do this in, but that's okay. All right. Next one is normalize. And this one takes no arguments and is a return type of void. So that's pretty easy. We have vector3 add. Public static vector3 add. So add takes another vector3. So vector3 of b, and this is marked as static. I think that those are actually typos from where I pulled them from somewhere else, because if we're doing static, we really want, well, yeah, like this, subtract vector a and b, vector s and v. So the add probably was supposed to have a vector3a as well. You can see down there it does, but it wasn't in the definition, so this is technically what that UML should be according to what's in there, except it should be static, which static means that it needs to be underlined. But we kind of screwed up on that one. I did when I wrote this. It should actually be A, vector3, and then B, vector3 is really what we wanted. So use that instead. And then this needs to be, because this is static, it needs to be underlined. And the same for subtract. So A vector 3, B vector 3, and scale. S double and V vector 3. And that's it on the methods. So there's kind of our three pieces, three boxes of our UML diagram. And let's go ahead and draw a line. Here's our box. 1, 2, and 3. So method or fields and properties, methods, and the class declaration, class name. All right. So that was UML diagram for vector 3. And then here we have this one we might call out to the instructor. This is what was defined in the class, but I think you meant this. And we'll do another arrow. And just to make ourselves try to look a little more intelligent, we'll correct the spelling and let's undo the underline. And go ahead and draw another arrow. And this is technically was static, so it should also be underlined. So this kind of annotation, perfectly fine on your test. If you find something you think was a mistake, you can either reach out to me and ask, or you can also just make a note on the test itself. I will take those into account as I'm grading. If what you found is a definite error, then obviously I'm going to weigh in your benefit. If, on the other hand, you're misreading something, I'll provide a correction, an explanation to help you see what we're doing there. All right, last question on this practice exam. We have a student registry that has a list of students, which are these guys. You notice it's an aggregation. The student has a last name, a first name, a GPA, and a standing. And then we have a honor roll method, which gets us an enumeration of students. And we have a search by name and filter by standing. And the standing is out of this enumeration where we have freshman, sophomore, junior, senior, and super senior. So this must be a 4-year state college. Assuming a private variable students is already initialized, complete the student registry methods. Students with a GPA of 3.5 and above are on the honor roll. You may use linked methods. So we want to enumerate, grab all the students that are on the honor roll. And see, that was a enumerable. So we have an enumerable that we can iterate through, and we can do this either manually or with link. So we could do a var or a list. I'll go ahead and do it both ways. So we can iterate through our incoming students list. Honor roll students. And if s dot GPA is, and we go back to our description, 3.5 and above are on the honor roll. Greater than or equal to, because it includes the 3.5 students. If that's the case, we can say honor roll students, add S, and at the end, return honor roll students. So that's the old school way of doing it. If we're going to do it in link, we would just take students where S is dot GPA greater than or equal to 3.5, and we can return that. So this will generate a new list where this lambda is applied as a filter, so only the students who are greater than or equal to 3.5 in their GPA are going to end up on that list. So it's a lot less typing, a lot less writing, which is one of the reasons a lot of people really like LINQ. All right, next one. Search by name. So we need to find the student, and notice that we are returning a list of students. You might think that we should just return one student with that name, but a lot of times more than one student is going to have the same name. I've done enough years of helping with advising to know this. Public IEnumerable student. Search by name. And this must be looking through all the students then in the students list, which is a private list of students. So that's fine. Did I do that on the honor roll? Oh, notice honor roll did not take a IEnumerable at all. So take that out. And students was already defined, so we don't need to define it. But yeah, it's a private variable named students, so that should still work. We just don't need to bring it in as a parameter. String name. So basically the same kind of pattern. We'll create a list of student. I'm going to call it matches. And for each various and students, and let's do an if in here. If student.name equals, or we could do it contains. There's a lot of different ways we could do this. Name. This is going to make the two names have to match exactly, which there's not a lot of description here as to what we're expecting, so that would be fine. A lot of times we actually want to look for a substring, so you can just search for like the first 3 letters in the name or something like that, in which case we'd probably do something like contains, or do something even more custom where we're actually seeing if it's the first substring, something along those lines. So any of those would be okay here. Matches.add s. And the link way. And again, you don't have to, you just pick one or the other. You don't have to do both. I'm doing both just to demonstrate kind of the difference. Link, if you haven't looked at it yet, that's one of the chapters for this section. So you're going to get into that and see how that really works. So we could say students dot where again s dot name dot contains name, and return that. That's all there is to link. Up here, let's make sure that we're using capital N for the property name. There we go. And the last one, filter by standing. So we're bringing in a standing. We want only the students who have that standing. Public IEnumerable student filter by standing. And again, we'll do a list. This is a good place to use the var. All the var means is that the type is inferred. So in this case, it's going to be a list of students. And it's a good place to do it because we immediately construct it. So anybody who wants to know what his type is just has to look at this line. It's less typing. That's why you'll see it a lot in professional code, because professionals will try to go as fast as they can in their typing, and they're going to take the shorthand where the shorthand makes sense. The other place you often see it is in the for each. So this could be student S, or it could be var S, like we've done up here. They're equivalent because we're iterating over a list of students, so they're going to have the student's type. And basically you can use the var wherever it's going to be obvious what you're doing. And usually when the variable is used almost immediately, that's the case. So just something to keep in mind. So if student.standing equals standing, the standing we passed in. So if this is a freshman and we're looking for freshmen, we're going to say matches.add s, add that student, and at the end return matches. Pretty straightforward. And the link is even more straightforward, because all we have to bring in is that filter condition. Filter by standing. With the link, we will return students dot where s dot standing equals standing. So again, what this is doing, this is iterating through the list, just like we did here, and it's pulling out everybody for whom this condition is true. They get included in the returned list. Everybody who's not gets left out. So it's effectively the same as this. It's actually very similar internally into how it actually operates. It's doing a very similar thing. And the list that this returns is a new list, so it doesn't actually modify the students list at all. It just creates a new copy, just like we did here, where we create a new list and we copy things into it. All right, I think that is the end of our practice exam. One other note, it does say that this is just the vocabulary questions are omitted on the practice exam. I'm actually leaving the vocabulary questions off of the final as well, because we did a really heavy deep dive into the vocabulary with the midterm, and for the most part I was happy with that. Those of you that didn't do well on that, you can go back and submit your corrections, and I thought, well, these are exactly the same things I want you to define in the final, so if you are struggling with those on the midterm, you have a chance to get those points back by giving me the corrections. I didn't feel a need to actually force you to answer the same questions over again otherwise, so yeah, there won't be a vocabulary on this final for the summer course. There normally is for the regular course. So your final exam is going to look very similar to this. The biggest difference is all of the code diagrams and all of that is going to be on the last couple pages. So when you print it out, keep that one handy, because you're going to want to use it as a reference as you're working on the test questions. Be aware that they're going to reference that last page and you need to go back and take a look at it. All right, that is it for the final. Be sure that you review the instructions for taking the final. Make sure you reserve some significant time for doing that, and good luck.